So this is chapter 10. Chapter 10 deals with radical functions. And what we're going to do is focus on mainly square root functions and cube root functions to start off the chapter. So they're very similar, so I'm grouping them together. So we're going to start with definition of a square root function. So a square root function is a function that contains a square root with the independent variable in the radicand. So what you're going to have is the square root of x. So you could have square root of x plus 2, you could have the square root and then of x and then plus 3. You could multiply, you could have all these other different transformations applied to it, but your parent function is just the square root of x. And this is actually the inverse of a quadratic function. And later in the chapter, we'll go into more detail about what an inverse function is. But if you look sideways, you can see that it is a parabola, or the side of a parabola, one half of your parabola. So if you remember when we were graphing parabolas, you had that pattern of 1, 3, 5, and that's how you graphed it. What I want to show you here is that pattern as well. But instead of going up 1 over 1 and up 3 over 1 and get that parabola, that quadratic, you can go up 1 over 1, up 1 over 3, up 1 over 5. So that pattern still applies. You're just kind of switching the x and the y. So before you went up 1 over 1, up 3, now you're going up 1 over 1, up 1 over 3. So it's just the same idea, just switched a little bit. And if you notice, there's only half of it here, where a parabola was symmetrical and you had the U-shaped. So the reason why you don't have this bottom U here is because if you had both the positive and the negative, then it doesn't pass your vertical line test and you do not have a function. So that's why when you're just looking at the square root, you're either going to look at just the positive or just the negative, not both together. Then your domain and your range. So your domain and your range are specific to each graph. So if you're looking at this one, your domain starts at 0, 0 and goes all the way to the right. You don't have any negative numbers for your graph, so your domain is just x is greater than or equal to 0. So it's all the numbers that are greater than 0. And since the graph opens upwards, your range is going to be everything above 0. So your range is going to be y is greater than or equal to 0. So again, we'll look at domain and range of different examples as we go through, but it really all depends on this starting point here and what the graph looks like, whether or not it opens upwards or the downwards version. Okay, so again, this is what we went over, and I kind of described this already to you, but here's just another picture showing you how your quadratic and the inverse of it is the square root function. And again, you don't have both the positive and the negative when you're graphing a square root function. You'll either just have the positive or just have the negative. So again, I went over that pattern as well just before. Okay, so what we're going to do now is describe the domain of this problem. So what you're going to do is look at the radicand, because you remember you cannot take the square root of a negative. If you take the square root of a negative, you end up with no real solution. So what we're going to do is be taking the value of the radicand and setting it equal to 0. And the value of your radicand must be greater than or equal to 0. And from there, you can identify your domain. So take the radicand, x minus 5, and it has to be greater than or equal to 0, because again, your domain, but you cannot take the square root of a negative number. So from there, you can solve for x, and from there, you get your domain. So add 5 to both sides. So your domain is x is greater than or equal to 5. And this also goes into transformations. If you remember, minus 5 inside the function really tells you you're taking your graph and you're moving it to the right 5. So that's why instead of it being at 0, it's now at 5. Okay, so a radical function is a function that contains a radical expression. So a radical function can be both cube root function or square root function, fourth root function. A radical function is just the name of all the different types of functions that you can have. So a square root function is just a specific type of radical function. And again, we're going to look at transformations that we've looked at before with quadratics and linear functions as well, where you have a vertical and a horizontal translation where you're moving left to right, up and down, a reflection, a horizontal stretch or shrink, not too much. We're going to mainly focus on a vertical stretch and shrink. So first example. So right now what I have here is graphed the parent function, just square root of x. And what we're going to do is look at the transformations that are being applied to this function and how to graph it. So that negative sign indicates a reflection over the x-axis. So instead of it being the upwards curve, it's actually going to be a downwards curve. This -2 is actually a horizontal translation to the right 2. So again, when it's inside, it's kind of backwards. You would see a negative, but it's really going to the right. If you saw a positive, it's really going to the left because you're subtracting a negative number. So all of those rules from earlier in the year with transformations apply to this function as well. So your graph is going to be moving 2 units to the right, and instead of opening upward, it's going to open downward. And again, you take that point, and really you're only focusing on that one point here. So it's going over to the right 2, and then again, instead of going up, we're going to go down. So you're going to go down 1 over 1, down 1 over 3, then your next point would actually be down 1 over 5. So it still has that pattern, just inverted. And then for this one, your domain, which I didn't write, but your domain is going to be x is greater than or equal to 2, because it's at 2 and everything to the right. And your range is going to be y is less than or equal to 0, because it's everything below your x-axis. Oh, I did write it. Okay, another example. So you have negative is a reflection. 2 is your vertical stretch. So instead of it being up 1 over 1, you're going to be multiplying it by 2. So it's going to be going up 2 over 1. And it's going to be much higher. +3 to the left 3, and then +2 up 2. So again, you're really focusing on that one point here at 0, 0, and that's where the transformation is going to be applying. So you have left 3, so you're moving to the left 3, up 2 units. That's how you get to this point. So because we're opening downwards because of the reflection, so you have that downward curve, and you're multiplying that pattern by 2 in a way. So instead of going down 1 over 1, you're going down 2 over 1. And then instead of down 1 over 3, you're going to go down 2 over 3. Instead of down 1 over 5, you're going to go down 2 over 5. So you're just kind of stretching it by 2. So that's what your vertical stretch would be. And then cube root function have all the same properties as before, but instead your index is a 3 instead of a 2. But every other property still applies. The shape of the graph, though, is somewhat different. I'm actually going to stop this video here and start a new one just to talk about cube root functions.